Good morning, David. Here's Thomas. Welcome to my cave here in Würzburg, Germany. Yeah, your first question was how many systems are controlled by the flight engineer? And the answer is all systems. Everything is controlled by the flight engineer, which is a good thing. There's an SOP, standard operating procedure, how the flight engineer has to act. His flows and scans all written down. There are checklists for pilots and checklists for flight engineers. Both are challenged by the first officer and then answered either by the captain, the pilot's checklist, or by the flight engineer. You have to know that probably you know it, first officer cannot see the flight engineer's panel. Okay? And so he has to just believe that the switches are done and verified, and that the settings and the conditions are met that are challenged from the checklist. The good thing about the 747 Classic is you have more access to the systems. Okay, so I'm sorry, this is a very bad resolution here on this picture. All systems that the airplane has are drawn here on a board. Let's see it this way. Okay, here we have it in a little bit higher resolution. So as you can see, we're starting here with engines, with generators, with the APU. That's alone the APU panel. You know, on the 737, the APU panel is 2 gauges and 3 lights. You know, just to have a comparison, and everything was accessible for the flight engineer, and he had his flow pattern starting here at the indicator panel, the annunciator panel, and running down stripe by stripe. Okay, as you do it also on the overhead panel. The flight engineer was also helping the pilots to fly the airplane, because you have to know here the throttle quadrant and the appropriate full flight regime auto throttle was an auto throttle that was only good for cruise and approach and maybe landing. But it wasn't a full flight regime autothrottle. It couldn't do everything that modern autothrottles can do. The most important thing is that the autothrottle was not communicating with the pitch modes. So whatever pitch mode you were setting on this dinosaurs type of flight director of autoflight system here, or here you see it better. That's a three autopilot layout, which is fail operational. And here it's fail-safe, it's 2 autopilots. And everything there was its own world. It didn't communicate to each other. Okay, that was the disadvantage. So the flight engineer, when the first officer was pilot flying, and he was climbing from 4,000 feet to 8,000 feet. Let's go it this way. He had to do a lot of steps. On a modern airplane, let's compare it to the 747-400, it was just dialing 4,000 feet and press level change, that's it. And then just read the FMAs, the flight mode annunciators, that was it. On the Classic, that's a completely different story. On the Classic, to climb from 4,000 to 8,000 feet, for example, you had to turn around to the flight engineer and say, climb thrust. And the flight engineer pressed here where do we have it? Here. Here is a limiter panel for different thrust settings, and he had to press the limit for climb thrust, EPR, and then you set trim throttles. So climb thrust, trim throttles means he was advancing the thrust levers, and then he trimmed them to show the same EPR value, so that you have equal thrust on all 4 engines here. This is a tape type of indication. This is round gauges, but it means the same. So that was the job of the flight engineer, was helping the pilots to fly the airplane.